Assalamu alaikum. This is lecture 28 of Data Security and Encryption, and the title of this lecture is Network Access Control and certain topics about cloud security. So here are the lecture contents. The lecture will start with some description of network access control elements and some enforcement methods that enforce the rules on the network access control. There are some extensible authentication protocols, and there are some EAP extensible authentication protocol exchanges examples will be discussed. So a common EAP protocol is IEEE 802.1x port-based network access control. So after the discussion of network access control, the later part of this lecture will be about the cloud computing. Certain elements and the reference architecture of the cloud computing will discuss at first, and some security risks and countermeasures about the cloud security will be discussed, along with the data protection and cloud security as a service in the cloud environment. First of all, let's define a network access control. A network access control is an umbrella term for managing access to a network. A network access control authenticates users logging into the network and determines what data they can access and actions they can perform. It is very much similar to accessing any public or private network. Network access control also examines the health of users' computers or mobile devices, that whether they or not they are compatible to uh, join any network. So there are certain elements of network access control, and network access control deals with three categories of the components. The first component is the main component of the network access control, which are referred as U or access requesters. These are the nodes that are attempting to access the network, and it may be any device such as a mobile or a computer or any other workstation, and it will be managed by network access control system, including servers, printers, cameras, and other IP enabled devices. This is also referred as supplicants or clients. The second component of the network access control is the policy server, which determines what access should be granted, and it often relies on backend systems. So the main component of a network access control system is a network access server, and it functions as an access control point to users in a remote locations connecting to an enterprise internal network, and it is also called a media gateway remote access server or a policy server as well, and it may include its own authentication services or rely on a separate authentication service from the policy server. So this figure presents a generic network access diagram. A variety of different network access requesters, referred as supplicants or ARs, and this may be a laptop, a personal computer, or a mobile, seek to access to an enterprise network by applying some type of network authentication server. The first step is generally to authenticate the supplicants, and it is referred as authentication server. The authentication typically involves some sort of secure protocol to use the cryptographic keys. Authentication may be performed by the network authentication server, or the network authentication server may mediate the authentication process. So in the second case, the authentication takes place between the supplicant and authentication server, that is a part of a policy server or that is accessed by a policy server. The authentication process serves a number of purposes. It verifies the supplicant's claimed identity, which enables the policy server to determine what access privileges, if any, they have. The authentication exchange may result in the establishment of session keys to enable the future secure communication between supplicant and the resource enterprise uh, network. Typically, the policy server on the supporting server will perform checks in the supplicants to determine if it should be permitted interactive remote access connectivity. These checks, sometimes called health stability uh, screening or assessment checks, and this requires software on the user system to verify the compliance with the certain requirements from the organization's secure configuration baselines. For example, if the user's anti-malware software must be up to date, the operating system must be fully patched, and the remote computer must be owned and controlled by the organization. These checks should be performed before granting access to the enterprise network. Based on the result of these checks, the organization can determine whether the remote computer should be permitted to use interactive remote access. So if the user has acceptable authorization credentials but the remote computer does not pass the health check, the user and the remote computer should be denied network access or have limited access to quarantine network, so that the authorization personnel can fix the security deficiencies. The figure also indicates that the quarantine portion of the enterprise network consists of the policy server and the related suitability servers. There may be also application servers that do not require the normal security threshold to be met. So once the supplicants have been authenticated and cleared for the certain level of access to the enterprise network, the network authentication server can enable the supplicants to interact with the resources of enterprise network. The network authentication server may mediate every exchange before the security policy for this supplicant, or may use another method to limit the privileges of the supplicant. So network access server can enforce certain methods. The actions that are applied to supplicants to regulate the access to the network enterprise network. Many vendors support multiple enforcement methods simultaneously, allowing the customer to tailor the configuration by using one or the combination of the following methods. The common network access control enforcement methods are as under. The first one is referred as IEEE 802.1x. This is a link layer protocol that enforces the authorization before a port is assigned to an IP address. It makes use of the Extensible authentication protocol for authorization process. We will discuss this protocol in the later part of this lecture. The next is the virtual local area network enforcement method, and in this approach the enterprise network, consisting of an interconnected set of LANs, is segmented logically into a number of virtual LANs. The network access control system decides to which of the network the virtual LANs it will direct and supplicant, based on whether the device needs a security remediation, internet access only, or some level of network access to enterprise resources. Virtual LANs can be created dynamically, and virtual LAN membership of both enterprise servers and supplicants may overlap. This is an enterprise server, or a supplicant may belong to more than one virtual LAN network. Another enforcement method is to place a firewall. A firewall provides a form of network access control by allowing and denying network traffic between an enterprise host and an external user. Another enforcement is placement of DHCP. DHCP server. The Dynamic Host Configuration Protocol is an Internet protocol that enables the dynamic allocation of IP addresses to host. A DHCP server is very important in most of the enterprise networks. A DHCP server intercepts the DHCP request and it assigns an IP address instead. Therefore, the network access control enforcement occurs at the IP layer based on the subnet of the IP assignment. A DCHP server is easy to install and configure, but is subject to the various forms of IP spoofing, providing limited security. Therefore, there are a number of other enforcement methods available from the vendors. The ones that is preceding this are perhaps the most common, and IEEE 8021X by foremost is the commonly implemented solution. So the most important protocol is EAP, Extensible Authentication Protocol, and it is defined in RFC 3748, acts as a framework for network access and authentication protocol. Extensible Authentication Protocol, pronounced EAP as short, provides a set of protocol messages that can encapsulate various authentication methods to be used between the client and the authentication server. The EAP can operate over a variety of network and link level facilities, including point-to-point links, LANs, and other networks, and it can accommodate the authentication needs of various links and networks. This figure illustrates the protocol layers from the context of EAP layer, and which has the authentication methods which you have seen in many of the wireless authentication methods such as EAP TLS, TTLS, PSK, and IKE with along others. And there is an EAP layer which extends the IEEE 8021X protocol, which is implemented over the LAN, and the certain protocols are implemented on the data link layer as well. So EAP layer protocol supports multiple authentication methods. This is what meant by the referring to as an EAP as extensible. The EAP provides the generic transport service for the exchange of authentication information between client system and authentication server. The basic EAP transport service is extended by using specific authentication protocols that is installed in both the EAP client and the authentication server. Numerous methods have been defined to work over the EAP protocol, and commonly supported EAP methods are EAP transport layer security, EAP tunneled TLS, generalized pre-shared key, and IKEv2. The first method refers to the transport layer security, and it defines the protocol, and it can be encapsulated in EAP message. It uses the handshake protocol in TLS, not its encryption method, and client and server authenticate with each other using the digital certificates. In the second EAP tunneled TLS is like the EAP TLS transport layer security method, except only the server has the certificate to authenticate itself to the client first, then the clients authenticate themselves to the server. The EAP generalized pre-share key is an EAP method for mutual authentication and session key derivation using the pre-shared key. It specifies an EAP method based on the pre-shared keys and employs secret keys based on the cryptographic algorithms. However, this method is efficient in terms of message flows and computational costs, but different. It requires the existence of pre-shared keys between each EAP server. The final method, EAP IKE, is based on the Internet Key Exchange Protocol IKE version 2. It supports the mutual authentication and session key establishment using a variety of the methods. So these figures indicate a typical arrangement in the EAP is used. There are some certain components which are described here. The first one is an EAP peer, and it is a client computer that is attempting to access a network. Then we have an EAP authenticator, which is an access point to network access server, and it requires the EAP authentication prior granting to access to the network. And the third component is authentication server itself, a server computer that negotiates the use of specific EAP method with an EAP peer and validates the EAP peer's credentials and authorizes the access to the network. Typically, the authentication server is a remote authentication dial-in user service, which is pronounced as radius in short. The authentication server functions as the back-end server, and that can authenticate the peers as a service to a number of EAP authenticators. The EAP authenticators then make the decisions of whether to grant access to the peers. This is referred as EAP pass-through mode. Less commonly, the authenticator makes over the role of the EAP server, that is, only two parties are involved in the EAP execution. So as the first step, a lower level protocol such as point-to-point protocol or IEEE 8021 is used to connect the EAP authenticator. This software entity in the EAP peer that operates at this level is referred as supplicant. The EAP messages containing the appropriate information is chosen. EAP method are then exchanged between EAP peer and authentication server. So this figure gives an example of an EAP exchange message. So not shown in this figure is that a message or a signal sent from the EAP peer, which was the first step, to the authenticator using some protocol other than the EAP requesting an EAP exchange to grant access. The first pair of EAP request and response message is type identity, in which the authenticator requests the peer's identity and the peer provides the EAP response identity. The response passes through the authenticator to the authentication server. The subsequent EAP messages are exchanged between peer and authentication server. So upon receiving the identity response message from the peer, the server selects the EAP method and sends the first EAP message with the type field related to authentication method. So if the peer supports and accepts the EAP authentication method, it replies with the corresponding response message of the same type. Otherwise, the peer sends the NAK message. The EAP server either selects another EAP message or aborts the EAP execution with the failure message. The selected EAP method determines number of request response pairs. During the exchange, the appropriate authentication information, including the key material, is exchanged. The exchange ends with the server determines that the authentication has succeeded or the authentication has failed. IEEE 802.1x port-based network access control was designed to provide access control functions for local area networks. This table briefly defines the terms used in the IEEE 802.11 standard. The terms supplicant, network access point, and authentication server correspond to the EAP terms peer, authenticator, and authentication server respectively. Until the authentication server authenticates the supplicant using the authentication protocol and authenticator only passes control and authentication messages between the supplicant and the authentication server, the 802.1x control channel is unblocked, but the 802.11 data channel is blocked. Once the supplicant is authenticated and keys are provided, the authenticator can forward the data from the supplicant subject to the predefined access control limitations for the supplicant to the network. Under these circumstances, the data channels is unblocked. So you can go through the number of definitions in this table. So this figure shows an 802.1x access control which uses the concept of controlled and uncontrolled ports. Ports are logical entities and defined within the authenticators and refer to the physical network connections. Each logical port is mapped to one of these two types of physical ports. An uncontrolled port allows the exchange of protocol data units between the supplicant and the authentication server, regardless of the authentication state of the supplicant. A control port allows the exchange of the data between supplicant and other systems on the network only if the current state of the supplicant is authorized. The essential element defined in this protocol is known as EAPOL over LAN. OL stands for over LAN, and EAPOL operates at the network layers and makes the use of IEEE 802 LAN such as Ethernet or Wi-Fi standards. So EAP-OL enables the supplicant to communicate with the authenticator and supports the exchange of EAP packets for authentication. So that ends the discussion of the EAP protocols, and the next topic is the cloud computing. So there has been an increasing prominent trend in many organizations to move a substantial portion of even all information technology operations to internet connected infrastructure known as enterprise cloud computing. So NIST defined the cloud computing in NIST SP 800-10145 standard. The NIST definition of cloud computing is as follows: a model for enabling a ubiquitous, convenient, and on-demand network access to a shared pool of configurable computing resources such as networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model promotes the availability and is composed of five essential characteristics, three service models, and four deployment models, which will be discussed subsequently. First of all, the definition refers to the various models and characteristics whose relationship is illustrated in this figure. The essential characteristics of the cloud computing are described in this slide. So first of all, we have the broad network access essential characteristics. which are the capabilities that are available over the network and access through the standard mechanism that promote use of heterogeneous thick or thin client platforms such as mobile phones, laptops, and personal digital assistants, as well as other traditional or cloud computing based software services. Then we have the rapid elasticity component, in which the cloud computing gives you the ability to expand and reduce resources according to your specific service requirements. For example, you may need a large number of service resources for the duration of specific task. You can then release these resources upon the completion of the task. Then you have a layered service. Cloud systems automatically control and optimize resources by leveraging a metering capability at some level of abstraction appropriate to the type of service. For example, for storage, processing, bandwidth, and active user accounts. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service. Then the cloud computing must provide on-demand self-service. A consumer can unilaterally, unilaterally provision computing capabilities such as the server time and network storage as needed automatically without requiring human interaction with each service provider. Because the service is on demand, resources are not permanent parts of your IT infrastructure. And it should provide the resource pooling as well. The provider's computing resources are pooled to serve multiple consumers using multi-tenant model with the different physical and virtual resources dynamically assigned to and reassigned according to the consumer demand. There is a degree of location independence in the customer generally has no control or knowledge of the exact location of the provided resources, but may be able to specify location at high level of abstraction, for example, country, state, or data center. Examples of resources include storage, processing, memory, network bandwidth, and virtual machines. Even private clouds tend to pool resources between different parts of same organization. After the essential characteristics, there are some service models, and NIST defines three service models which can be viewed as a nested service alternatives. So first of all, at the lowest level, the cloud computing provides the software as a service. This capability provided to the consumer is to use the provider's applications running on cloud infrastructure. The applications are accessible from various client devices through a thin client interface such as a web browser. So instead of obtaining a desktop and a server licenses for software products it uses, an enterprise obtains the same functions from the cloud service. Software as a service saves the complexity of software installation, maintenance, upgrades, and patches. Examples of this service is the level of Gmail, Google's email servers, and Salesforce.com, which help firms to keep track of their customers. At the second level, the cloud provides the service of platform as a service. This capability provided to the consumer is to deploy onto cloud infrastructure consumer created or acquired applications created using the programming language and tools supported by the provider. Platform as a service often provides middleware style services such as databases and component services for use by applications. In fact, the platform as a service serves as an operating system into the cloud. At the deepest level, it provides the infrastructure as a service, and this capability provides the consumer is to provision of processing, storage, networks, and other fundamental computing resources where the consumer is able to deploy and run softwares, which can include operating systems as well and applications. Infrastructure as a service enables customers to combine basic computing services such as number of crunching and data storage to build highly adaptable computer systems. Finally, NIST deploys certain deployment methods. So first of all, the kind of uh, deployment of the cloud can be a public cloud. The cloud infrastructure is made available to the general public or large industry group and is owned by an organization selling cloud services. The cloud provider is responsible for both cloud infrastructure and for the control of the data and operation within the cloud. The cloud can also be private. This cloud infrastructure is operated solely by the organization. It may be managed by the organization or a third party and may exist on the premise of premise. The cloud provider is responsible only for the infrastructure and not for the control. It can also use the hybrid uh, technique. The cloud infrastructure is composition of two or more clouds, a private, public, or a community cloud that remains unique entities but the bound together by standardized proprietary technology that enables data and application portability, such as cloud bursting or load balancing between clouds. Cloud can also be on the community based. The cloud infrastructure is shared by several organizations and supports specific community that has shared concern. For example, mission, security, requirements, policy, and compliance consideration. It may be managed by the organization or a third party and may exist on the premise or off premise. So this figure is the typical representation of a cloud service context. An enterprise maintains the workstations, usually the local computers, within an enterprise LAN or set of LANs which are connected with each other through the LAN switches and routers. And these networks are connected to the cloud provider using a general purpose router. The cloud service provider maintains a massive collection of service providers servers, which it manages for a variety of network management, redundancy, and network security tools. In figure, the cloud infrastructure is shown as a collection of blade servers, which is a common architecture. So NIST also defines the cloud computing reference architecture, which establishes a reference architecture described as follows. So the NIST cloud computing reference architecture focuses on the requirements of what cloud services provide, not a how to design solution and implementation. The reference architecture is intended to facilitate the understanding of operational intricacies in cloud computing. It does not represent the system architecture of a specific cloud computing system. Instead, it is a tool for describing, discussing, and deploying a system-specific architecture using common framework of reference. So this figure shows uh, NIST Cloud Computing Reference Architecture. The NIST developed the reference architecture with the following objectives in mind. First of all, NIST aims to illustrate and understand the various cloud computing services in context of overall cloud computational network. It aims to provide a technical reference for consumers to understand, discuss, and categorize and compare the cloud services, and it aids to facilitate the uh, analysis of candidate standards for security, interoperability, and portability, and reference implementation. So the reference architecture is depicted in this figure, and it defines the five major actors in terms of roles and responsibilities. The first of all, the cloud consumers. So a person or an organization that maintains a business relationship with and uses the service from cloud providers is referred as cloud consumers. Then the important part of the cloud is cloud providers. a person or an organization or entity responsible for making services available to the interested parties, and it can have various forms of services such as software, platform, or infrastructure services along with other cloud service management tools, security, and privacy servers. The third component is a cloud auditor, a party that can conduct independent assessment of cloud services, information systems operations, performance, and security of the cloud implementation. The fourth party is the cloud broker. It is an entity that manages the use, performance, and delivery of the cloud services and negotiates the relationship between the cloud providers and cloud consumers. And finally, the cloud carriers. It is an intermediary that provides the connectivity and transport of cloud services from cloud providers to cloud consumers. So the roles of cloud consumers and providers have already been discussed. To summarize, we can provide a brief overview here that the cloud providers can provide one or more cloud services to meet the IT and business requirements of the cloud consumers. For each of three services models such as software, platform, and infrastructure, the cloud provider provides the storage and processing facilities needed to support the service model together with the cloud interface and cloud service consumer. So for software as a service, the cloud provider deploys, configures, maintains, and updates the operations of software applications on a cloud infrastructure, and that services are provisioned to expected services level to cloud consumers. For platform as a service, the cloud manages the computing infrastructure for the platform and runs the cloud software that provides the components of the platform, such as routine runtime software, execution stack, databases, and other middleware components. For infrastructure as a services, the cloud provider acquires the physical computer resources underlying services, and it includes the servers, network, storage, and hosting infrastructure. So there are certain roles and responsibilities in the cloud computing environment. First of all, we have a cloud carrier, which is a networking facility that provides the connectivity and transport of the cloud services between cloud consumers and cloud providers. Typically, a cloud provider will set up a service level agreement with the cloud carrier to provide services consistent with the level of service level agreements offered to cloud consumers, and may require the cloud carrier to provide dedicated and secure connections over the cloud consumers and cloud providers. A cloud broker is useful when the cloud services are too complex for a cloud consumer to easily manage. There are three areas of support that can be offered by a cloud broker. First of all, it provides the service intermediation with the value-added services such as identity management, performance reporting, and enhanced security. Cloud broker also provides the service aggregation, which combines the multiple cloud services to meet the consumer needs not specifically addressed by the single cloud provider, or to optimize the performance or minimize cost. Finally, it provides the service arbitrage. A broker has the flexibility to choose services from multiple agencies. The cloud broker, for example, can use a credit card scoring service to measure and select the agency with the best score. Finally, a cloud editor is an independent entity that can assure that cloud provider conforms to a set of standards. In general terms, the security controls in cloud computing are similar to the security controls in any IT environment. However, because of the operational models and technologies used to enable the cloud service, cloud computing may present risks and specific to the cloud environment. The essential concept in this regard is the enterprise loses a substantial amount of control over resources, services, and applications, but must maintain accountability and security for security and privacy policies. The Cloud Security Alliance (CSA) lists the following as the top cloud-specific security threats, together with suggested countermeasures. So first suggested threat is the abuse and nefarious use of cloud computing. For many computing uh, cloud providers, it is relatively easy to register and begin using cloud services, some even offering free limited trial periods. This enables attackers to get inside the cloud and conduct various attacks such as spamming, malicious code attacks, and denial of service. Platform as a service providers have traditionally suffered most from this kind of attacks. However, recent evidence shows that the hackers have begun to target infrastructure as a service as well. So this burden on the cloud provider to protect against such attacks, but cloud service client must monitor activity with respect to their data and resources to detect any malicious behaviors. So countermeasures include stricter initial registration and validation processes. You can also use enhanced credit card fraud monitoring and coordination, along with comprehensive introspection of customer network traffic. And you can also countermeasure by monitoring public blacklists for one-ounce network blocks. The other threat is the insecure interfaces and APIs, and cloud providers expose a set of software interfaces or APIs that consumers use to manage and interact with cloud services. The security and availability of the general cloud services are dependent upon the security of these basic APIs. From authentication and access control to the encryption and activity monitoring, these interfaces must be designed to protect against both accidental and malicious attempts to circumvent policies. The countermeasures are analyzing security models of cloud provider interfaces, ensuring that the strong authentication and access controls are implemented to connect with the encryption machine, and understanding the dependency chains associated with the APIs. The other risks are malicious insiders. Under the cloud computing paradigm, uh, an organization relinquish direct control over many aspects of security, and in doing so confers an unprecedented level of trust onto the cloud provider. One grave concern is that risk of malicious insider activity. Cloud architectures necessitate certain roles that are extremely high risk. Examples include cloud provider system administrators and managed security service providers. The countermeasures is to enforce again strict supply chain management and conduct a comprehensive supplier assessment, specify human resource requirements as part of a legal contract, require transparency into the overall information security management and practices, as well as compliance reporting. And you can also do the determine security breach notification processes. Another threat is a shared technology issues, and infrastructure as a service vendors deliver their services in a scalable way by sharing infrastructure. Often the underlying components that make the use of infrastructure, such as CPU and GPU, were not designed to offer strong isolation properties for a multi-tenant architecture. The cloud providers typically approach this risk by use of isolated virtual machines for individual clients. This approach is still vulnerable to the attacks, both insider and outsiders, and so can only be part of an overall security strategy. The countermeasures is to implement installation, configuration, monitor environment for unauthorized changes activity, and access control for administrative access and operations, and enforce SLAs for patching and vulnerability remediation, conduct vulnerability scanning and configuration audits. The data loss and the leakage is another form of attack, and for many clients, the most devastating impact from a security breach is the loss of data or the leakage of data. So the countermeasures to overcome these problems is to implement a strong API access control, encrypt and protect data integrity of the data in transit, and analyze data protection at both design and runtime, implement strong key generation and storage management and destruction practices. The final two kinds of attacks are account or service hijacking and unknown risk profile. So in account or service hijacking, usually with stolen credentials, remains a top threat. With stolen credentials, attacker can often access critical areas of deployed cloud computing services, allowing them to compromise the confidentiality, integrity, and availability of these services. Countermeasures are to prohibit the sharing of account credentials between users and services, leverage strong two-factor authentication techniques where possible, and employ proactive monitoring to detect unauthorized activity along with the understanding of cloud provider security policies and SLAs. For unknown risk profile in using cloud infrastructure, the client necessarily cedes control to the cloud provider on a number of issues that may affect the security. Therefore, the client must pay attention to and clearly define the roles and responsibilities involved in managing risks. For example, employees may deploy applications and data resources to the cloud provider without observing the normal policies and procedures for privacy, security, and oversight. The countermeasures of disclosure of applicable logs and data, partial and full disclosures of infrastructure details, and monitoring and alerting the necessary information. So as it can be seen from the previous slides, there are numerous aspects of the cloud security and numerous approaches of providing cloud security measures. A further example is seen is in the NIST guidelines for cloud security specified in SP 814 and which are listed in this table. So you can go through these topics to understand further about the security aspects and the countermeasures in the cloud security environment. There are many ways to compromise data. The deletion and alteration of the records without the backup of the original content is an obvious example. Unlinking a record from a larger context may render it unrecoverable, as can storage on unreliable media. Loss of an encoding key may result in effective destruction as well. Finally, unauthorized parties must be prevented from gaining access to the sensitive data. So the threat of the data compromise increases in the cloud due to the number of interactions between risks and challenges that are either unique to the cloud or more dangerous because the architectural and operational characteristics of the cloud environment. Database environments used in the cloud computing can vary significantly. Some providers support multi-instance model, which provides a unique database management system running on a virtual machine instance for each cloud service subscriber. This gives the subscriber complete control over the role definition, user authorization, and other administrative tasks related to the security. So other providers supports a multi-tenant model. which provides a predefined environment for cloud subscriber that is shared with other tenants, typically through tagging data with a subscriber identifier. Tagging gives the appearance of an exclusive use of the instance but relies on the cloud provider to establish and maintain a sound, secure database environment. So the data must be secured while at rest or in transit or in use, or in access to the data must be controlled. The client can employ encryption key to protect data in transit. Through this involves key management responsibilities for the cloud provider. The client can enforce access control techniques, but again the cloud provider is involved in some extent of depending on the service model used. For data at rest, the ideal security measure for the client is to encrypt the data and only store encrypted data in the cloud, with the cloud provider having no access to the encryption key. So long as the key remains secure, the cloud provider has no ability to read the data, although the corruption and other denial of service attacks remain a risk. A straightforward solution to the security problem is, in this context, to encrypt the entire database and not provide the encryption-decryption keys to the service provider. However, this solution is still inflexible. In this way, the user has the little ability to access the individual data items based on the searches or indexes on the key parameters. The user would have to download the entire tables from the database, decrypt the tables, and work with the results. To provide more flexibility, it must be possible to work with the database in its encrypted form. So an example of such approach is described in this slide, and four entities are involved. The first entity is concerned is the data owner, which is an organization that produces the data to be made available for the controlled release either within the organization or to the external users. The next item is the user itself, human entity that present requests to the system. The user could be an employee of the organization who is granted access to the database via the server, or an external user or of the organization who, after the authentication, is granted access. They can be a client, which is a front end that transforms the user queries into queries on the encrypted data stored on the server. So original query is generated to the query processor, which transforms the query to the cloud server, which is the fourth element, which is an organization that receives the encrypted data from the data owner and makes them available for the distribution to the clients. The server could in fact be owned by the data owner, but more typically this facility is owned and maintained by an external provider. So this is a cloud server which requests the data from the data owner, which provides the metadata to the client, and which decrypts the plain text to the user. So this leads to the definition of cloud security as a service. The term security as a service has generally meant a package of security services offered by a service provider that offloads much of the security responsibilities from an enterprise to the security service provider. Among the services typically provided are authentication, antiviruses, anti-malware or spyware, intrusion detection, and security event management. In the context of cloud computing, cloud security as a service designated as SecaaS, is a segment of software as a service offering of a cloud provider. The Cloud Security Alliance defines cloud security as a service as a provision of security applications and services via the cloud, either to the cloud-based infrastructure and the software, or from a cloud to the consumer on from on-premise systems. The Cloud Security Alliance has identified the following security as a service categories of service. These include the identity access management, the data loss prevention, web security, email security, security assessment, intrusion management, security information and event management, encryption, and business continuity and disaster recovery and network security. So this figure describes some elements of the cloud security as a service. The first element is the identity and access management network security service. Which includes people, processes, and systems that are used to manage access to enterprise resources by assuring that the identity of the entity is verified and then granting the correct level of access based on the assured identity. The access management portion of identity and access management involves authentication and access controls services. For example, the server must be able to authenticate users in a trustworthy manner. The access control requirements in the environment includes establishing trusted user profiles and policy information, using it to control access within the cloud service, and doing it in an auditable way. The second component is the data loss prevention, which is the monitoring, detecting, and verifying the security of data at rest, in motion, and in use. So data loss protection can be implemented by the cloud client, uh, the, which can provide data loss protection services, such as implementing rules about what function can be performed on data in the various contexts. The next element is the web security, is a real-time protection offered either on premise through software appliances installation or via the cloud by proxy or redirecting web traffic to the cloud provider. This provides an added layer of protection on top of things like antiviruses to prevent malware from entering the enterprises via activities such as web browsing. In addition to the protecting and against malware, cloud-based web security services might include usage policy enforcement, data backup, traffic control, and web access control. The next element can be the email security, which provides control over inbound and outbound email, protecting the organization from phishing, malicious attachment, and enforcing corporate policies such as acceptable use of spam prevention. This uses the digital signatures on all email clients and provides optional email encryption. The security assessment, security information, and event management is the next element, which is a third part audits of cloud services. While these services are outside the province of the servers, this cloud service provider can provide the tools to access points to facilitate the various assessment activities. The next element is the intrusion management, which encompasses the intrusion detection, prevention, and response. The core of this service is the implementation of intrusion detection systems and intrusion prevention systems at entry points to the cloud and the service in the cloud, and intrusion Detection system is a set of automated tools designed to detect unauthorized access to the host, and an intrusion prevention system incorporates the intrusion detection system functionality, but also includes the mechanism designed to block traffic from intruders. The other component is the element of encryption, which is pervasive service that can be provided for data at rest in the cloud, email traffic, client-specific network management information, and identity information. Encryption service provided by the CSP includes a range of complex issues, including key management, how to implement the virtual private network services into the cloud, and application encryption and data content access. So that is the end of this lecture, and in this lecture we discussed about the network access control, and the elements of the network access control were discussed along with the extensible authentication protocol method. Then in the later part of the lecture we discussed about the cloud computing elements and its reference architecture, and we analyzed some cloud security risks along with the countermeasures to overcome these risks. And finally, data protection mechanism in the cloud is discussed. So if you want to study more about the topic, you can read chapter number 16 of the recommended book, or you can ask me any questions. Thank you very much.